is GR, which is the inbuilt part of, we can say, HLR. As already we have seen related to the HLR into the GSM architecture, the HLR is responsible, or we can say HLR stands for home location register, which maintains the information of all the users or GSM users of that service provider. In addition to this, that HLR is consisting of the additional new element called as Gprs register, which will not keep the information of all the GSM users, rather which will store the information of only the Gprs users and the relevant data related to that user into this Gprs register. In short, we can say that the Gprs register is also a static database of all the Gprs users who is using the Gprs data service, which is not the separate element into this Gprs architecture, which is the inbuilt part of HLR itself. Then we will move towards the another entity, that is mobile station. The mobile station is nothing but, we can say, it is the device which is used by the different users for the data transmission. Whenever the mobile station, or we can say whichever the device the user is used for the data transmission, that mobile station are required to use all the Gprs services, because existing phones do not handle the enhanced air interface or packet data network. It means that, in short, we can say that whichever the device we are going to use for the data transmission, that device must have the services for enhancing, or we can say to handle the air interface, as well as which is required, or which requires the packet data network into the during the transmission. A variety of mobile station can exist, including high-speed version of current phones to support high-speed data access. Sometimes the new PDAs, that is portable device assistant devices, can be used by the different users via GSM phone and PC cards for laptop computers. Those mobile stations are backward compatible for making voice call using GSM. It means that whichever the device which we are going to use for the data transfer, which also consists of the calling service, or we can say calling facility, by using the GSM architecture, or we can say by using GSM. Then the next part is, that is base station subsystem. As we know that each BSC requires the installation of one or more packet control units and software upgrade. So the base station subsystem consists of number of such BSC stations which need to be upgraded by the packet control units, and in addition to that, those BSC station also require some software upgradation to use this data service for the data transfer. Whichever the packet control unit which is included or required into the BSC station, which is responsible or which provides physical and logical data interface to the base station subsystem for packet data traffic. In short, or in other words, we can say that the PCU, that is packet control unit, is responsible for the packet data traffic transfer during the transmission. So by which we can transfer the data in terms of packets into the Gprs, or you can say data transmission. In addition to that, whichever the different BTS stations which are used into the Gprs architecture, or you can say Gprs transmission, which also requires some software upgrade, but which does not require any upgradation into the hardware, or you can say into the hardware of BTS station. In easier word, we can repeat this point as whichever the different BTS stations are used into the GSM architecture, which will require the upgradation into the software, but which will not require any enhancement or modification used in the hardware of BTS station. Whenever either voice or data traffic is organized at the subscriber mobile, it is transported over the air interface to the BTS station, and from the BTS to BSC in the same way as standard GSM call. It means that whenever the user will transfer the data to any another user, it is transport, or that data is transferred or transported over the air interface to the mobile or to the BTS station, and the BTS station will forward that data to BSC station as the same way which is used into the standard GSM. Then we will move towards the last part, that is MSC. However, at the output of BSC, a traffic is separated. Voice is sent to mobile switching center as per standard GSM procedure, and data is sent to new device called as SGSN via PCU over a frame relay interface. In easier word, I repeat this point as MSC, or you can say whenever the data, or you can say the user will use any service, or whenever user will use the voice service into the Gprs system, or you can say GSM system, that data, or you can say that voice communication or transmission is forwarded to this mobile switching center, whereas whenever user will use the data service, the data is transferred to SGSN, that is surveying Gprs support node, via PCU, that is packet control unit, over the frame relay interface. The GGSN and SGSN can be compared with the home and foreign agents respectively into the mobile IP network. So we can say that GGSN is into the home network, whereas SGSN is in the foreign network for the data transmission. Whenever the packet data is transmitted from PDN via GGSN and SGSN directly to BSC and finally to the MS. It means that whenever the packet data network will transfer any packet to the mobile station, that data, or you can say that packets are forwarded through GGSN and SGSN via BSS and finally to the mobile station. The MSC, which is responsible for data transport in the traditional circuit switched GSM, is only used for signaling into the Gprs scenario. So in case of simple GSM architecture, we have seen that the MSC station is responsible for the data transmission, or you can say voice communication. But in case of Gprs architecture, or you can say packet switched data transfer, this MSC is responsible only for signaling into the Gprs scenario. Before sending any data over Gprs network, an MS must be attached to it. It means that the mobile station need to go through the attachment procedure for forwarding, or we can say for sending any packet to any of the user into the Gprs architecture. The attachment procedure is nothing but the attachment procedure includes assigning temporal identifier called as temporary logical link identity, that is TLLI, and assigning ciphering key sequence number, that is CKSN, for data encryption. It means that the attachment procedure is nothing but assigning two different numbers, that is TLLI, that is temporary logical link identity, and the another number is ciphering key sequence number, which is allocated or assigned to that mobile station into the attachment procedure. For each mobile station, Gprs context is set up and stored into the mobile station after this attachment procedure and corresponding SGSN. The context has the status of mobile station, which can be of three different states such as ready, ideal, or standby. The CKSN and flag indicating if compression is used and routing data, that is TLLI, routing area RA, cell identifier, and packet data channel, in addition to PDCH identifier. It means that the context has the status of the mobile station, which consists of all this information of each of the mobile station whenever the attachment procedure is finished for that user. Besides attaching and detaching, mobility management also has the functions for authentication, location management, and ciphering. Here, the scope of ciphering lies between mobile station and SGSN, which is more than standard GSM. It means that whenever user want to transfer the data, the security is enhanced as compared to GSM. It means that the security is only in between mobile station and BTS station into the GSM architecture, whereas into the Gprs architecture the security is in between mobile station and SGSN, which consists of BSS, then BTS, all these elements which are covered under the security aspect. Whenever an ideal mode of the mobile station, it means that the mobile station is not reachable into the Gprs service, or you can say into the Gprs architecture. It means that whenever mobile station is in the ideal mode, whichever the context which is created for that mobile station is deleted from this Gprs architecture, or you can say from this Gprs service. In the standby state, only movement across routing areas is updated to the SGSN, but not changes of the cell. It means that whenever the user is in standby mode, only the routing information is updated to the SGSN, but which will not update the change in the cell of that mobile station. And whenever the user is in ready state, it indicates that user is ready for the data transmission, or can say receiving the packets into the transmission. This is nothing but about all the elements of Gprs architecture. So we have seen the different elements such as gateway Gprs support node, then surveying Gprs support node, then Gprs register, then mobile station, then base station subsystem, then MSC, that is mobile switching center, which are the part of this Gprs architecture. This is the most important point as per the university exam front of view. this question was asked so many times for 8 marks, that is explain GPRS architecture. So whenever the question will be asked on this GPRS architecture, the expected points are, first you need to draw the GPRS architecture block diagram, then you have to explain all these elements or network elements of this GPRS architecture one by one, and at the last you can just mention the various interfaces which connects the different parts, such as the interface which is used to connect the mobile station and base station, the GB interface which is used to connect the BSS and SGSN, which also includes or contains GN interface which connects SGSN and GGSN, and another interface, that is GI interface, which connects the GGSN and packet data network into the GPRS architecture. So you have to explain what is GGSN, what is SGSN, what is GR, MS, mobile station, MSC, and we have to explain GB, GN, GI interfaces used into this GPRS architecture. Thank you.